Right, guys, exercise 5C, part 2. Let's get straight into it. So these are the only two examples that we'll be looking into, and they're quite intimidating looking examples. But as long as you know your difference of perfect squares and also factorizing the quadratic expressions, you should be able to cancel down very, very smoothly. Let's look at the first one here. Sorry if I sound very breathy. I had a just looked into my other video and it seems like I'm taking a lot of breaths. I think it's because I'm laying down on my bed while I make this. So apologies if it's really annoying. First thing we're going to do with this one, we have x squared minus x minus 6 all over x plus 2. Now we're in a scenario where there is no coefficient that we can see that is in front of this x, but there is one, and namely it is -1. Okay, so if you want to put this invisible 1 here and actually indicate that there is a 1 there to make factorizing this easier, then by all means you can at the start. We are going to be looking for two numbers. We're going to factorize this first, and we're going to be looking for two numbers that when multiplied will give me -6, and then when added will give me -1. Now I know that one of these has to be x plus 2 of some case, or namely a 2. Because they wouldn't put this here in the first place, because this will be simplified down, or this will be cancelled out. So let's look for these two numbers. This is going to turn into x all over x plus 2. And we know that one of them has to be a plus 2. So that means what number when multiplied by 2 will give me -6? Well, this has to be -3. And just to double check, a -3 plus 2 will give me -1, which is this -1 that we have here. So this right here is a simplified version down. I kind of took a bit of a shortcut to get from one to the other. Remember, I was looking for two numbers when multiplied will give me -6, and when added will give me -1. This is +2 and -3. Now we can go ahead and cancel this even further, because these are being multiplied together. They're two separate terms being multiplied. They're not added in between or subtracted in between. We can cancel that x plus 2 with the x plus 2 that's at the bottom, and what we'll be left with is just an x minus 3. So this here is a combination of simplifying or factorizing this first, and then simplifying where we can, where it follows. In other words, if you're looking at this and you're getting from this step here to the bottom step, if I were to choose an x, a number for x, and substitute it into here and derive some type of solution, I can also do that, find an x value, put it into here, and get the same solution. The only difference is this one is way easier to work out as opposed to the first one, and this is the whole reason why we simplify these type of algebraic expressions or fractions. B, this monstrous looking question can be simplified down further down. We can see here we've got difference of perfect squares. We've got these quadratic expressions here that are monic, which I know there are 3 of them, so they got the tri, and we're going to see what we can do to try to simplify this down. So I look at the first one. So I always write this down first. It just gives me a better feel. I know it sounds a bit wacky, but I like writing the expression down, even though I know it's up there. I get into this habit of writing it out first myself, so I can see what I'm dealing with. I don't know why, it's a bit weird. Okay, the first one is a difference of perfect squares, because this right here is a square number. If it wasn't, we can still do a difference of perfect square, but this can be written as, from a previous skill from exercise 5b, x plus 3, because the square root of 9 is 3, x minus 3. That's our first part. Alright, so the numerator within this first fraction. The second one, we can try to look for a number when multiplied together will give me -15, and then when added together will give me -2. In this case here, I know one has to be a positive and one has to be a negative, because this is a negative constant. This right here The two numbers will be 5 and 3. We just got to figure out which one is positive and which one is negative. If I make the 5 of this negative, so negative 5 plus 3 will return me to negative 2. So this has to be x minus 5 and x plus 3. As minus 5x plus 3x will give me negative 2x. And negative 5 times positive 3 will give me negative 15. Okay, there's the first part. Second part, we have another expression here that's quadratic that we can simplify down further. We're looking for two numbers that when multiplied will give me negative 5, and then when added will give me negative 4. So this one here, let's make this line there we go. The two numbers that I can think of is 5 and 1. So the negative 5, one has to be positive and one has to be negative because this constant is negative. If it was negative 5 and positive 1, negative 5 plus 1 will return me to negative 4. So it has to be x minus 5 and x plus 1. So negative 5 times 1 gives me negative 5. Yep, negative 5x plus 1x, negative 4x. That works out. And then the last one here, this is a linear. It's not quadratic, but I know that 2 can be taken out as a common factor. So what I'll be left with is x minus 3. Now this times here just unifies all the numerators together and all the denominators together, so we can do any type of cross cancellation rather as well. So if I see an x minus 5 on the top here, I can cancel that one with this one here. I see an x plus 3 at the bottom here, so I can cancel it with that one. I also see an x minus 3 and an x minus 3 there. There's no more that I can cancel down. So what I'll be left with is, on the top is a 1 and a 1 and a 1, just x plus 1 on the top. And on the bottom, I just have a 2. I should write this formally without the brackets now. This is all x plus 1 over 2. So we are harnessing our skills from this exercise and the two previous ones to simplify something as monstrous as that down to something as simple and as majestic as x plus 1 over 2. This is the last example for the set work. Check your log sheet to see which questions you need to do, and I'll see you guys in the next video. Delio!